Welcome to the video. Today, we're going to explore how to visualize data when working with a single feature. Whether it's categorical or numerical data, you'll learn key techniques to analyze and communicate information clearly using Python's Seaborn library. Let's jump right in. In this presentation, we'll cover three main areas. First, we'll learn how to interpret visualizations for categorical features, such as bar charts. Second, we'll dive into visualizing numerical features like histograms, density plots, and box plots. Finally, we'll see how to construct these plots using Python and Seaborn. By the end of this video, you'll have a solid understanding of these visualization techniques and how to implement them in code. Let's start with visualizing categorical features. Categorical data divides a dataset into distinct groups or categories. The most common plot for categorical data is a bar chart, where the height of each bar represents the count or frequency of items in each group. If you're more interested in proportions instead of counts, you can use a relative frequency bar chart. Both of these charts are simple, yet powerful tools for identifying patterns and distributions in your data. Next, let's look at the first code example. This snippet uses Seaborn to create a bar chart. It plots a simple dataset where continents are grouped and their counts are displayed. By specifying the data and axes, Seaborn makes it easy to produce clean, readable visualizations. The next slide contains the figure generated by our first code snippet. It shows a bar chart created using Seaborn, visualizing the count of countries grouped by continent. This chart allows us to quickly observe which continents have more countries in this dataset and identify patterns across groups. Now let's move on to numerical features. When working with numerical data, the goal is to understand how values are distributed across a range. Three common visualizations for numerical features are histograms, density plots, and box plots. A histogram groups values into bins and shows how many fall into each range. A density plot is a smooth approximation of a histogram, which gives a continuous curve representing the data's distribution. Finally, box plots summarize the spread of the data by displaying the minimum, first quartile, median, third quartile, and maximum values, while also highlighting any outliers. In the next code example, you'll see how to create a histogram using Seaborn. This code plots the distribution of years of schooling and adds a density curve to better illustrate the shape of the data. By adjusting the number of bins, you can get a more detailed or summarized view of the data. The next slide contains the figure generated by our histogram code snippet. It visualizes the frequency distribution of years, with bins dividing the data into smaller ranges. The density curve provides a smoother view of the data's shape, allowing us to identify trends and patterns in the dataset. Box plots are incredibly useful for summarizing numerical data. They provide a concise visual representation of the spread and central tendency of a dataset. Key elements include the box, which represents the interquartile range, a line for the median, whiskers that extend to the minimum and maximum values, and points representing outliers. Box plots are especially valuable for spotting differences between groups or identifying unusual data points. In this example, we see how to generate a box plot using Seaborn to visualize the years of schooling in a dataset. The next slide contains the figure generated by our box plot code snippet. This plot summarizes the distribution of years, highlighting the median value, interquartile range, And outliers? Box plots are an excellent tool for comparing distributions or quickly understanding the spread of a dataset. To summarize, we explored visualizing categorical features using bar charts and relative frequency charts. Then, we discussed numerical features and how to represent them using histograms, density plots, and box plots. Finally, we saw how to implement these visualizations using Python's Seaborn library. These techniques are fundamental for analyzing and communicating insights from data. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.